On the number line, show the inequality x is less than 4. You always read from letter. A smaller crocodile mouth means less than. So here x is less than 4. On our number line, locating first of all where x equals to 4, in this case here, we always start by drawing open circle. As I want the values of x to be less than 4, the way the arrow faces, it's facing to the left. So less than 4 are numbers like 3, 2, 1, etc. You must draw the line the full way, as we want all the values that are less than 4. As we want values of x to be less than 4 and not include 4, that's why it's an open circle. If it asks us to draw x is less than and have the extra line means equal to, it looks like an equal sign, then we'd start by drawing a circle above 4 and we'd colour in the circle to indicate that we can include it. If you see two inequality signs, we always read for the middle. Here y is greater than 3 and y is less than and equal to 7. We're told where y is an integer is a whole number. It has no decimal part. We're asked to write down all the possible values of y. As you want to find all possible values of y, and you've got two inequality signs, you always want the letter, in this case y, in the middle by itself. We always start on the left. As I want y to be greater than 3, as it hasn't got the extra line, that means I can't include 3. So the first integer after 3, if I keep adding on, well, 3 add 1, the first integer therefore is 4, and 4 is greater than 3 and less than or equal to 7. The next integer after 4 would be 5. And I keep going until I reach this number. So 5, next integer will be 6. Then I reach 7. As we have the extra line under the 7, therefore we can include it, because here y is less than and equal to 7. Solve means to work out. In this case, I'm working out the value of x. As I currently have x's on both sides of my inequality, my first step is to get all the x terms on one side and my number terms on the other side. As I have more positive x on the left, as I've got positive 3x, I've only got positive single x on the right. I'm going to bring all my x terms across the left. If you move a term over an inequality, it's the same as an equation. It's going to change sign. So it's positive x on the right. Bring it across the left. It's now going to change sign. It's going to become negative x. So I'm going to subtract x on both sides to keep my equation balanced. On the left-hand side, 3x subtract x will give us 2x. And I've still got plus 5. And that's still greater than or equal to. We know on the right, x subtract x will cancel. That leaves us just with 17. Now I've got all my values of x on the left-hand side. Therefore, my number terms on the right. Hence, I'm going to be the positive 5 from the left-hand side across the right. If it goes across an inequality sign, we know it changes sign. So the opposite, add 5, is going to subtract 5 from both sides. On left-hand side, 5 subtract 5 will cancel, and that will leave us just with 2x on the left. It's still greater than and equal to. On the right side, 17 subtract 5, that will give us 12. Well, I know 2x in algebra means 2 multiplied by x. As I want to find the value of x, the opposite of times by 2 is I'm going to divide both sides of my equation by 2. On the left-hand side, 2 over 2 will cancel, doink, to leave us with single x. It's still greater than and equal to. On the right side, 12 divided by 2 gives us 6.